So friends, I would like to welcome all of you to this month webinar series. So today we are going to be talking about GC tuning and its case studies, right? So this is a monthly webinar series, so we'll be conducting it every month. So I would like to warmly welcome all of you to this month's webinar series, GC tuning, Fortune 500 case studies on cutting costs and boosting performance. Okay, friends, so let's get started, right? Let's start off with this question. What is garbage? So what is garbage as per your definition, right? So whoever the attendees are there, please put your answer into the chat, right? What does garbage means to you? So feel free to give your answers, whoever is there. Okay. See, typically when I ask this question, I hear answers like some people unreferenced objects which are no longer needed in memory, right? So these are all very valid definitions. But I will say, what is my version of garbage? What is the definition of what is my definition of garbage towards the end of this session? Okay. But now let's try to understand what is garbage actually within the JVM, right? So friends, look at this. See here, all our applications, all our JVMs have a memory, right? We declare XMX, the memory size. We set it as 2 GB, 6 GB, 10 GB, 20 GB. Even if you declare as 100 GB, 200 GB, there are some JVMs which has a half a terabyte XMX, right? Even if you set to such a large value, still at the end of the day, it is a finite space. This is still a finite space. Let's see what happens when a request comes to this memory. Let's say a sign-on request comes to your application. Let's say a sign-on request comes to your application. This application, just to service a simple sign-on request, our application is creating thousands of objects. So what are those thousands of objects? Let me say a few of them, right? So when a servlet request comes, we are creating a servlet request object. We create a servlet response object, and then we create a servlet object. And if you're going to use Spring Boot kind of a frameworks, then it creates its own set of objects. And then let's say it's going to go through your application code. So it's going to come to your data access object. And then it's going to create a database connection object. Now with the connection, it's going to make a backend call. Now your database is going to respond back with the details. That's going to be a result set. So your application is creating thousands of objects just to service a very simple vanilla request. Okay, so now I created all these thousands of objects. Now I service the request. Now I authenticated. Yes, this based on the record data I got. We can say either the request is authenticated or not authenticated. So now the request goes away. Now what will happen to these objects you created now? See, all these objects are sitting in memory. And these objects is no longer needed, right? Because the request came, we created object, request is gone. Now these objects are orphaned. There's no more reference to it. So we have to remove these objects from memory. Only if we remove these objects from memory, there's going to be room to create new objects to service a new incoming request. So these objects, which is of no longer reference, they are called as garbage. And they are called as garbage. Friends, how was this garbage, the objects that we create in memory, how is that removed from memory? How is it evicted from the memory? And like 3-4 decades back, if I was a developer, it was my responsibility to remove these objects from memory. See, 3-4 decades back, see today as a Java developer, today I only create an object. I only say new customer object, new account object, new connection object. I only say new and create object. I don't write a code to remove these objects from memory, right? But back 3-4 decades back, it was as a developer, it was my responsibility to deallocate, to remove these objects from memory. So I need to write a code to remove these objects from memory. So 3-4 decades back, there was one problem was going on. It was, say, as you can imagine, all our business applications are very complex, right? It has multiple use cases, multiple lines of code, multiple workflows. Even if it's in one use case, if as a developer I miss to deallocate the objects I created for that particular use case, then those objects will start to grow in memory. And if this object keeps growing in memory, when you go past that your memory limit, then you're going to confront out of memory error. So memory leaks and out of memory error was pretty pervasive back in those days. So when Java came into existence, 3 decades back in 1995, it promised to the development community, allow developers, you don't worry about deallocating the objects. As a runtime environment, it is my responsibility to deallocate the objects from the memory. It gave that promise and it delivered. So developers really loved it, right? Because so now they can just focus only on the business logic. They do not worry about deallocating the object. And management loved it because less out of memory errors, it means high availability. So Java really championed this automatic garbage collection. See, even before Java, even before 1995, there are few languages which was giving that automatic garbage collection, but not all of them were not having that capability. But since Java came, since it was very welcomed by the development community, since then, every language that is coming, all the modern language that is coming, they have this automatic garbage collection. And this automatic garbage collection is a wonderful feature. It's a wonderful feature, but it has two side effects. What are those two side effects? Right? The first side effect is it pauses your JVM. That is, pause means it stops your JVM. See, friends, just for a simple sign-on request, we are getting thousands of objects. Assume if your application process multiple concurrent requests. So anytime in your memory, there is millions or billions of objects is there. So your garbage collector, what it has to do is it has to scan through all those millions or billions of objects which is there in memory. It has to investigate every single object and has to see whether it has any active reference or not. How does it check whether it will have active reference? That means it has to walk through the entire object hierarchy. Say there is this object. It needs to check whether this object has a parent. Then it has to examine that parent. And this parent will have a grandparent. It has to examine that grandparent. It has to walk through the entire hierarchy to see whether, okay, now I have come to this grandparent. Does this grandparent have any more reference? No, there are no references. So then it can be removed from memory. So it has to scan all these millions of objects, which is there in memory. So a garbage collector is a heavy CPU consuming operation. It consumes enormous amount of CPU cycles. Say if your application is going to have like a 60% is your CPU consumption, average CPU consumption. Probably 40% of the CPU consumption is made by garbage collector. Yes. So it consumes enormous amount of CPU cycles. And the second one, what does it do is this garbage collector, it stops your JVM. It pauses your JVM so that it can see, so that it can continue investigation. And this pause time can be few hundred milliseconds, seconds, sometimes it can be even several minutes. So when it stops, that means what does it happen? There is two problems happening there. When it stops, that means if any customer transaction that is coming in during that time, they will not get a response. If your customer says, oh, your application was responding properly, but all of a sudden it didn't respond for a few seconds, later that I got the response, then very likely the garbage collector is running in the background, right? This is one problem with this process. The second problem is, let me show the second problem a little bit sooner in my next slide. But now I want to show you a real case study of a GC performance in one of the major cloud provider. So this problem was happening in one of the critical service on one of the very top cloud hosting service provider. There's a good chance that some of us who is here in this webinar, your applications can be running, maybe running on this cloud provider because it is such a popular cloud provider. And this problem was happening in their one of the critical service. What was happening was that service was very slow, very poorly responding, and the customers were complaining. Let's look at the GC performance of this critical service of this cloud provider. Let's look at the garbage collection report. I'll tell you how to get this report and all those things for your application. So if you guys have a question, please feel to put it in the chat, right? I will look into it and then I respond, okay? So let's look at this here, my friends. So here, this is that garbage collection performance of that cloud provider. Let's look into this GC duration. So this section of this garbage collection report tells how much time this application, this JVM is stopping, it is pausing. So here you can see this is for a 24-hour period. So let's just zoom in for a particular time window. Let's just zoom in for a couple of hours. Okay, I zoomed in. Now look at this, my friends. I moved it on one dot. Look at that. Here, one GC event which ran at 11:27 a.m. in the morning. Here, this GC event stopped this application for 14.42 seconds. That means if any request that would have come at 11:27, it will not get any response for next to 14 seconds. It's not going to get response. Only after this GC event completes, then it's going to go ahead and process the next request. So the customer is not going to get response. Now moving along, look at this. This event ran at 11:27, 11:34, 7 minutes later. Once again, another garbage collection event is running to reclaim the memory. And this is stopping for another 14 seconds. See, this was 11:34, and now I'm moving on to the next event, 11:40. 6 minutes later, and another GC event is running, which is stopping the JVM for 14 seconds. You can see like this, it's continuously pausing. So if this is pausing like this, of course, any application that is running on this JVM is not going to get response because it's stopping for every 6 minutes, it's stopping for 15 seconds. So the performance were really degrading. So friends, when it comes to this garbage collection study or garbage collection tuning, there is one primary metric that what you want to be looking at. That metric is called as a GC throughput. See, here it is reported as 96%. So this critical service of a major cloud provider, its throughput, GC throughput is 96%. Friends, how does 96% throughput sounds to you? How does it sound to you? Right? See, for most of us, when I say 96%, it sounds very good, right? Because if I get this, if my high school daughter gets this grade, gets 96%, I'm very happy, right? It's a grade. But friends, I don't know who is that person who coined this metric, throughput in percentage. I don't know who is that person. I want to meet that person once in my lifetime to see how cleverly they have done it. Friends, reporting the throughput in percentage is highly deceiving. Let me say why it is deceiving. For that, let's look at we need to understand what is throughput means. So let's look at what is throughput means. If someone says my application's GC throughput is 96%, what it's reporting is, this means this application is spending 96% of its time in processing the customer transactions. In a day, it's spending 96% of its time in processing the customer transaction, remaining 4% of time in processing the GC activities, right? Because GC activity, when it runs, it stops. So this means this application is stopping for 4% of its time. And 96% of its time, it is processing the customer transaction, right? It doesn't look very bad right now because it's reported in percentage. But let's say if I'm going to look at it in the time, in the actual time, let's look at it, what it is. See, one day has 1,440 minutes because 24 hours multiplied by 60 minutes. What is 4% of 1,440 minutes? 4% of 1,440 minutes is nothing but 57.6 minutes per day per JVM. That means this critical service is stopping for 60 minutes, almost 60 minutes for 1 hour per day. It is stopping. Not doing any work. It's doing garbage collection, but it's not a productive work. It's not processing any customer transaction. That is, for one day, it is kind of sleeping for 1 hour. It's sleeping for 1 hour. Think what will happen. Let's say, think this. Let's say I'm an employee. I go to my work every day, and then I sleep there for 1 hour. What will happen? Most likely, I may lose my job, right? But the modern platforms are not losing the job. See, and there's also another thing that is happening here, my friends. Just because my JVM is sleeping for 1 hour, it doesn't mean my cloud hosting provider. Let's say we are all running our applications on the cloud infrastructure. If my JVM is sleeping for 1 hour per day, it doesn't mean the cloud hosting provider like say Amazon or GCP or Azure, they are not going to be stopping. They're going to stop the billing for me. They bill me on an hourly basis. My EC2 instances are built on an hourly basis. I don't care whether a garbage collecting and stopping, but I will continue to keep billing for you. So they are billing for us. So look at this. There is actually 3 problems compounding here. First one, for the 60 minutes, any transaction that comes, the customer is not going to get response. First problem. Second problem, my cloud provider is going to keep billing me, even though I'm not doing any productive work. The third problem, I'm having a very enormous CPU consumption. Because of that, my cloud cost is also going high. So let's try to put a dollar value around this garbage collection, right? What does it mean? So here is the dollar value computation, right? Look at this, my friends. Let's say your throughput is 96%, your application throughput is 96%. It means it is stopping for, in a one day, it is stopping for 57.6 minutes. That means in 1 year, at this throughput, it's going to stop for 350 hours. 350 hours is roughly like kind of a 2 weeks. Your JVM is going on a holiday while it's still working. Okay? Say, assume your organization, who are your mid-sized organization, who is running on 1,000 EC2 servers. Let's say you're running on 1,000 EC2 instance. Here I just did a rough calculation, assuming you're running on 32 gig Red Hat Linux machine on North California region. That means the cost of it is 57 cents per hour. If I multiply this 350 hours across 1,000 instances, then I'm talking about burning 200,000 US dollars, because I'm paying to cloud provider, but I'm not getting any real value for my customers. Let's say you're a large organization who are running on a 10,000 EC2 instances, right? That means you're talking about burning 2 million US dollars. Very high number. And if you're a very large institution, a very well-established financial institutions or major tech companies, you're running on 100,000 EC2 instance, then you're talking about burning 20 million US dollars per year, right? In your cloud. Yes. Now, look at this. There are some technology-centric executives. They are recognizing this. Say, this is Sridhar Vemu. He's a chief executive officer of Zogo, one of the large SaaS platforms. So he's saying in his conservative estimate, the Apple languages, they don't do this garbage collection parsing, due to which it is saying they're able to save $5 billion in his conservative estimate. But if we take all of our applications, which is running on all the languages, which is doing this automatic garbage collection, right? We're easily talking about several hundreds of billions of dollars being wasted because of garbage collection. The sad part of is, a lot of us doesn't even know it's getting wasted. That's the sad part. But friends, and here's a very good case study, Uber, a very large car ride-sharing application, right? They did the GC tuning because the cloud computing cost was ballooning out. So what they did, they did a GC tuning across the 30 mission critical services, and they were able to reduce like a 70,000 CPU cores, helping them to save millions of dollars in computing. A real case study, right? Now, let me also show not only the cost. See, here is a case study. You guys can go and take a look at the link, right? I will share this deck with you. Here, this is one of the top automobile manufacturer, very top automobile manufacturer. Probably several of us are driving this car. So they, in their middleware platform, they had an average customer-facing response time was 1.88 seconds. Right? That was their average response. That was baseline response time that was facing the customers. And their number of transactions which was timing out was 0.7%. But friends, just by doing a GC tuning, just by making a GC setting changes. What is GC setting changes, my friend? At the end of the day, I'm just tinkering my JVM arguments. That's all I'm doing. I'm just changing my JVM arguments. When I change my JVM arguments, look at this. They were able to drop their response time from 1.88 seconds to 0.95 seconds, which is 50% reduction. 50% reduction. Think about, see friends, there are a lot of engineers we are here in this webinar. Take a second, look back in your career, turn back in your career, you have a very rich career, worked on multiple companies. Think how many times you are able to optimize your overall application response time. Maybe we could have done what we have in most cases, what would happen is we might have refactored few backend calls, SQL queries, and we might have optimized few of the transactions response time. Yes, but here, when you tune your GC, your entire application, all the transactions response time gets better. because JVM GC operates at the foundational level. So your entire transaction gets better. And that too, the beautiful part is without this is the most beautiful part, you don't have to change or refactor a single line of source code. It's a very low risk change. You don't have to touch the source code. Just by modifying the JVM arguments, you can give this upliftment, right? So it's very, very wonderful thing to do this GC tuning. Okay. So now let's switch a little bit gears and let's talk about how to conduct this GC tuning, how to do this study. So how we can bring this same impact to your organization. Let's study that. So friends, how many garbage collection algorithms are there in Java 11 onwards version? How many garbage collection algorithms are there? You're welcome to put it in the chat, right? So friends, actually in OpenJDK, there are 7 GC algorithms: serial, parallel, CMS, G1, Shenandoah, ZGC, and Epsilon. So there are 7 algorithms, okay? And friends, do you know how many GC and memory related JVM arguments that you can pass to your application? How many GC and memory related arguments are available? Anyone want to take any guess? Actually, there are 600 plus arguments are there, right? See, friends, this can be a little bit overwhelming for anyone. There is 7 algorithms just on OpenJDK. So if you take Azul, OpenJN, those JVM, they have their own algorithms. And we have like a 600 plus GC arguments, right? So it can be overwhelming, intimidating for a lot of developers, right? So it's not overwhelming just for you. It's just a comical, this one. So it's not overwhelming just for you, even for me. See, I am doing this for living for last several years. Even this is overwhelming for me, right? So this is just a comical picture which shows a guy who was trying to understand GC. Before he had a lot of hair. After that, he lost hair. So it's not overwhelming just for you, even for me, and for several people who was doing it can be overwhelming. But friends, don't worry, don't fear at all. In this webinar, I'm going to be sharing with you few techniques, few foundational principles. With these foundational principles, you can definitely do a wonderful GC tuning and bring a very positive impact to your organization. There are some few foundational principles which never changes. Even today, there are 600 arguments. Tomorrow, let it go to 700, 800 arguments. The GC algorithm, let it multiply. Still, don't worry. There are some foundational principles which I'm going to be sharing, through which you can bring a very positive impact to your organization, to your entire organization. Okay. So friends, let's now study what are the key performance indicators when doing a GC tuning. Friend, there is this very famous saying, you cannot optimize what you cannot measure. So when I'm trying to optimize something, you need to understand what are the metrics against which I need to be conducting my GC study, right? So what are those key performance indicators when it comes to garbage collection tuning? The first metric when it comes to GC tuning is the latency. So what does latency means? Latency means when one garbage collection event runs, how much time does it take? What is the average pause time of one garbage collection event? Okay, here it's 34 milliseconds. And then also, you just don't only want to see the average, you also want to look at the maximum pause time. What is the maximum GC pause time? You want to look at that. And also, it's good to study the distribution. That is, within 0 to 200 milliseconds, how many events completed? 200 to 400, how many events? You want to see the distribution. So this is the first metric. And then what is the second metric? The second metric is the throughput. So the throughput is what we studied earlier. So throughput is, I want to look at a cumulative time period. In a cumulative time period, let's say for 24 hours or 48 hours, how much time my application is spending in processing the customer transaction and how much time it's spending in the garbage collection activity. So one should aim for always a high throughput, right? So that you spend more time in processing the customer transaction. And one should aim for a low pause times so that you're minimizing the customer impact. They don't have to, they'll get a response quickly. So friends, the third metric, what I want to call it as, these are called as a macro metrics. So these I'm calling as a micro metrics, very targeted for GC. And this is a macro metric. So what is this one is? What is my memory size? What is my Java process memory size? Because the bigger the process, then you ought to pay a price. You may have to pay a price in the garbage collection. Smaller the memory size, because when the memory is small, then the garbage collection time is also going to be smaller. So that is one metric. The second one is the CPU time. See, friends, as we discussed earlier, the garbage collection is a heavy CPU intensive operation because it's scanning millions of objects which is there in memory. So I want to know what is the CPU time. So when I'm doing a GC tuning, okay, with this setting number 1, my CPU time was this much. Okay, I went on to setting number 2. Then is my CPU time getting better or it's getting worse? So I want to look into that, right? Friends, and then the next and the most important metric is the response time. What is my customer facing response time? Okay, in my setting 1, my response time was 1 second, average response time. In setting number 2, my response time is getting to become like a 750 milliseconds. In setting number 3, maybe it's getting like a 1.5 seconds. So you want to study. When you do any performance study, it not just GC, any performance study, the most important metric is your customer facing response time, right? So you want to look into this. So friends, these are the key performance indicators. Okay. So now how we are going to source these metrics, from how we are going to source these metrics. We can source these metrics from the garbage collection logs, right? See, some of the KPIs that I showed earlier, some of them they are available. So they are partially available in the APM tools, right? But in depth, all the metrics are only available in the garbage collection log. So how we can get the garbage collection log? Friends, you can get the garbage collection log by passing these arguments to your JVM. So if it's Java 8, we can pass these arguments and give the file path so that the events will be returned to this file path. So if it's from Java 9, you want to pass this one and give the file path. So out of the file path give, that's why the GC log will be written and the JVM will be writing the events. Friends, enabling the GC log on your JVMs in production will not add any noticeable overhead. There is a white paper in our blog. You can look at it. So we have conducted a very exhaustive study. So the GC log does not add any noticeable overhead to your application. It not only helps you to do GC tuning, it also helps you to forecast your memory problems very early. So we'll talk about that in a next webinar about a forecasting of the memory problems, but not now. We'll keep it focused on how to do the GC tuning. So enable the GC log, and the GC log is going to contain all this information. How does the GC log looks like? So GC log is going to look like this. It's going to be with the numbers and the regions and all this. It's pretty cryptic. It's not very easy or not trivial to understand, but still you can develop expertise to look into that, but it's not very trivial. And friends, this GC log format, it varies by who is a JVM vendor, whether it's Oracle, HP, IBM, Azure, OpenJDK, or what version of Java you are running on, and what type of GC algorithm you are using, and what arguments you are passing. Based on this, your GC log will vary. So today in the world, there is like a 80 or 90 different type of GC logs. Hey, look at this. So this is a GC log if you're going to use a G1 GC algorithm. Looks totally different. This is a GC log if you're going to use a concurrent mark and sweep algorithm, different format. If you're running on an IBM JVM, they print it in XML structure. If you're going to run it on IBM, modern version of IBM JVM, it's XML structure, but a different schema. And if you see Android runs on a modified version of JVM, they also pause. See, this is how their structure looks. And Android has a modern ART version. This is how that GC log looks. So if you see, there's multiple GC logs, and it's not very trivial to look into this. So friends, you want to be using, these are some of the tools available in the market. So you can pick and choose which tool you want to use to do the analysis. I'm giving you all of them. You don't want to take my opinion to know which is the best GC log analysis tool, because I'm going to say GCEC because we are the builders of it. So you may want to dismiss my opinion. So you do the due diligence and pick the tool which you like. But even without any bias, I can say GCEC is the best intuitive and natural tool to analyze the GC logs, right? So friends, now let's open up a GC log and let's do the analysis, right? So let's open it and let me show you how to do this GC log analysis. So here is GCEC tool. So friends, You can sign in. Okay, so I'm signed in. Okay, once you sign in, see friend, this tool is available online and also it's available as an on-prem installation. So you can download and install on a local laptop or on a corporate firewall and do it. So here you can upload a GC log file, what you generate, or you can just copy and paste the file, or there's also APIs. You can do an automated analysis from a production servers. So to forecast any problems. So now what I will do, I will upload this GC log file from one of the server. Okay, so I'm uploading it. So once you upload, the tool is going to analyze and going to generate a log analysis report instantly. So the tool has a lot of pattern recognitions and also a lot of algorithms to predict or to detect any problem that is happening in your application. See, it detected there's a memory leak is happening, and it also gives you recommendations on how to resolve it. And if any problems is there, it reports you. See, what happens is it also gives you pointed recommendations for your application. Like say, okay, it says this is the problem. Then it says increase the thread count. Oh, and then now you may point this argument, you can reduce it. So it gives kind of a pointed recommendation. Okay. So now, friends, okay, we saw these are the KPIs, right? These are the KPIs when it comes to the GC tuning, right? What is it? It's the latency, throughput, memory, CPU, and response time. So how we are going to get it from the GC log. So once you upload it, here the tool is going to report you the KPIs. You see here, there is this key performance indicator section. See here, it is reporting what is my throughput, 86%. What is my latency? The average pause time is 182 milliseconds. The max pause time is 1 second. What is my CPU time? 20 minutes, right? So these are the metrics, right? Latency, throughput, CPU time, and the memory. For this memory, you can get it here. The memory is documented. What is the size of all the regions? 9.11 GB. So you have all the metrics, but for this response time. But for the response time, all other metrics we have. How we can get how we can get this response time? See, friends, we can get this response time from your, whatever the traditional mechanism you are using today. So you can use the access log, or let's say if you're using a load testing tool, you can look it up on the load testing side, or you can look into some APM tools if they're reporting. So use that. So now we know from where to source all these metrics. Okay, so now let me also quickly show you what are the other parts in this report, what you want to be looking when you do the GC tuning. Here it shows the generation size. Here it shows the key performance indicators. And now here it shows kind of how is my memory usage looking like. You can see the memory is going up and down when garbage collection down. It goes up and down, up and down. But after a point, the garbage collection keeps on running, but the memory is not coming down. It means a clear indication this application is suffering from memory leak. And then here there is this pause time. How much time my GC is pausing, right? Here, if I move my cursor here, it tells me, oh, this is pausing for at 9:07, it's pausing for 1.7 seconds. So I get to see them, how much time it's pausing. And then also if you want to see how much bytes are getting reclaimed for whenever any event runs. So here you can see, oh, at this time it required like a 4.4 gigabytes. I can get to see how much is reclaiming. And if you want to see a generation wise, okay, my young generation, how it was looking. I can look. Old generation, how is it looking? I can look into all these metrics. And if you want to see even more, one GC event has multiple phases, more fine-grained metrics are reported for you here. All right? So we have all these things reported. Now, friends, now we learned what are the metrics, key metrics when you do the GC tuning, and then how to source them, that is get it from the GC log. Now, friends, the next one I'm going to show you. This is basically the secret sauce, right? What is that secret sauce? I have this kind of a GC tuning worksheet, right? The link is given. We'll share this deck with you, whoever is attending. So in this GC tuning worksheet, I have this kind of a worksheet. So in this worksheet, what I've done is, look, I've given this scenario. So what are the GC arguments, JVM arguments with which I'm launching? And then here I'm documenting, okay, this is my setting number 1. This is my baseline. This is how it is looking. And what is my measurement duration? That is, how long did I test? my garbage collection log. Friends, typically, this GC measurement duration is going to be reported at the very top for you. That is basically just says how much time my GC log I was analyzing, I reported. Friends, I would like to share a couple of best practices when doing this GC tuning. What is it is? First thing is, try to capture the GC logs from your production servers, right? And that because your GC behavior is heavily influenced by the traffic pattern. Based on your number of key transactions that's coming in and how much rate they are coming in, the garbage collection is going to influence. This is a problem we have been trying to solve several decades. All our performance lab does not mimic our production traffic, right? So the best case is try to do this GC tuning exercise in production itself, not on, say, you might be running on hundreds of, or maybe you're running on 10, 20 JVMs in production. Just take one single JVM. Take just one JVM. On that one JVM, try to give different GC arguments and then conduct a study and document it here, right? Because so that you'll have more accurate modeling you can do. And the second best practice I want to share is study at least for a 24-hour period. Why I say 24-hour period? Because sometimes your GC, you're in a 24-hour period, the application would have seen high traffic volume and also low traffic volume, right? So you want to take that, you want to model that, and you want to do that. So its best thing is to take one JVM from production, try to do a GC tuning changes for 24 hours, and then document it here. So what I'm documenting, look at this. Here I'm documenting what is my average pause time, max pause time, throughput, and what is my CPU time. Everything I'm getting it from the GC report. And then what is my memory size? What is my average time? And then here put this actual report. Now document it. Now let me show you a real example that what we did for one customer, right? See, here we documented, okay, for this customer, on this date, we conducted this. So these are the metrics, we're documenting it. Okay, so now if you see, we kept doing it for multiple iterations. Okay, on May 24, 29, 30, 30, June, we kept on doing multiple iterations, everything for a 24-hour period. So if you see, we have been doing for 24-hour period. Finally, we found this set of arguments is what giving the best performance characteristics for this application. So then we went ahead with it. That's all it is, my friends. So this is the secret sauce, nothing else. All the GC experts in the world, this is what they are doing. That is, they enable the GC log, study for 24-hour period in the production. They take it and then they document it. Do like this, kind of the settings. I will, in the next part of my webinar, I'm going to be talking with you how you can derive these arguments, right? So we try to put it and see whether if it is the right direction, then we go ahead. If not, we back it out. See, even this GC setting tuning, even this GC setting tuning, how we derive these arguments, I don't want to use this word, but primarily it is hit and trial. That's all it is. We put it, oh, we see it's getting better, then we go with it. Oh, if not, then we back it out. That's all we do. That's all the so-called JVM experts in the world are doing. So you can do this, and then you can bring wonderful results for your organization, right? So now what I will do, I'm going to be sharing with you in the next 20 minutes. I'm going to be sharing with you 9 GC tuning tips and tricks that what you can follow so that you can derive those arguments more accurately, and then you can bring that very wonderful positive impact for your organization. So what are those 9 tips? So friends, the first tip that what I want to share is start your GC tuning from the scratch. See, what do I mean by this? See, your application has been, all our Java applications have been running for 5 years, 10 years, 15 years. And it has, out of the 600 arguments, you would have your own share of arguments, GC arguments, JVM arguments would be present. We are always afraid to touch those arguments. It is there, it is running. We don't want to disturb it. Friends, but what is it is, those arguments are legacy arguments. The argument that are configured 10 years before is no longer relevant, because 10 years before, the default GC algorithm was a parallel GC. The JVM was giving a different performance characteristics. Now the default has become G1 GC. Now but you're still carrying those arguments with you here. So there is a lot of messes going on there. So get rid of all the arguments. and then study the result. See, friends, this what we're attending is a webinar. I give this as a workshop also. This workshop is also available online. You can also enroll online and then you can look into that. So one of the student who attended this workshop, in-person workshop, and we give this workshop for corporates. So if you want, you are welcome to engage with us if you want to learn more. So one of the attendee of that workshop was Ryan Smith. At the time of attending that workshop, he was working as a senior support engineer in CloudBees. He took my recommendations, what I'm sharing here, and then he applied. As you know, CloudBees is the parent company of Jenkins, one of the largest CI/CD pipeline, which is deployed in most of the organizations. So since what he did, he took my recommendations and he applied on the Jenkins deployment across multiple organizations, and he started to see phenomenal improvements. So then he took those improvements and then he started presenting in several DevOps conferences. This is some of the conferences where he shared. So he's no more popular than me, right? No one knows me, but Ryan Smith is quite popular, but I'm very happy for him. So for next 2-3 slides, I got his permission, and then I'm going to be showing the slides which he was presenting in his DevOps conferences, right? So let's look at it. So this was a slide from Ryan Smith deck, which he presented. So this is a real world data from a very big bank, a very major bank in North America. Look at their throughput. The throughput was 92%, and the pause times were 20 seconds. So these were the arguments with which they were running, right? They were running with these many arguments. Now, he got it off all the arguments. He told goodbye. He removed it, following my first recommendation. Just by doing this, look what had happened. From throughput, from 92%, it went to 99%. Nothing else he did. He just got it off those arguments which were there. Because, friends, JVM itself has a lot of heuristics, adaptive intelligence to tune and adjust it at runtime. So you don't want to add these arguments and be a baggage to the JVM. See, friends, right? In some organizations, there may be some team members in those organizations. Even if those are team members, they don't want to do anything productive. Even if they just keep quiet, and if they don't do anything, still we can just move forward more quickly and more aggressively. But just because they are there, they don't let us progress quick enough, right? They are more a hurdle, right? I hope you don't have any such engineers or in your department, but these arguments are like that. So once we get it off it, boom, the performance got a lot better, right? Okay, so now this is the next slide, once again from the Ryan Smith, who was a student of the workshop, which I gave. This is a pause time graph of a very big shipping company in North America. Look at the pause times. They were hovering in kind of this 20 seconds magnitude. They were hovering in kind of 20 seconds range. Now, friends, the second tip what I want to share is look into the GC causes. So in your GC log analysis report, there is a section called GC causes. If you scroll down, there is a section called GC causes. Here, look at this. There's a section called GC causes. Allocation failure, evacuation pause, these are all things. This may be very alien words. We don't understand. If you don't understand, just move your cursor here. Okay, this is what it means. It means it's getting too many objects. It's not able to recline. So understand. So based on these causes, come up with the arguments to address these causes, right? So you don't have to do, but what we do is, because based on your causes, here we at the top, if you go to this recommendation section, here we tell if it's allocation failure, then this is what you do. So increase your concurrent GC threads, read past this argument and reduce this value. So try giving these arguments and see whether it is improving, right? So, let's coming back here. So Ryan Smith. So the second GC cost, right? In the study of GC costs and based on their address. For that shipping company, what Ryan Smith was trying to tune, look at this. The second major reason for the GC pauses were system.gc. It is pausing for 24% of time. This is pausing for 11 minutes. It was causing a JVM to pause for 11 minutes. It's because of system.gc. What is system.gc? Friends, system.gc is basically an API call which is available for developers. So as a programmer, I can invoke the system.gc. When I invoke the system.gc, what will happen is JVM will trigger a full garbage collection. Friends, this is not a recommended approach to explicitly call system.gc. There are one or two corner cases where I've seen a legitimate use, but most of the time it's not legitimate to use this API because think about it. What's happened? The JVM has internal heuristics, internal algorithms to trigger when the GC needs to be triggered. So now let's say JVM might have just triggered a GC. Now, once again, from your application code, if you're going to trigger it again, then you're going to incur 2 GC pauses when there is no need at all. So that was going on here. If that kind of a thing happens, you want to disable the explicit GC calls. How can I disable that? See, you can, if it's your source code, you can scan your source code and see where you're calling system.gc and go ahead and comment it. Right? That is one option. But what if this is system.gc is triggered from your third-party libraries or frameworks? So when they do it, then we don't have a choice. How can we do? So that's when, friends, this argument will be facilitating you. There is this argument called disable explicit GC. When you call this argument, then even if from an application code, if someone calls the system.gc, the JVM will discard it. JVM will ignore it so that you will not incur the system.gc pause. So now Ryan Smith, he configured this disable explicit GC. When he did it, boom, look at it. The CPU, there was a 3,500% performance increase. Earlier, the pause times were like at 23 seconds. From there, look, it dropped to 660 milliseconds. The average was only 89 milliseconds. Phenomenal improvement by disabling this explicit GC, right? Now, moving along. Next tip, what I want to share is try changing your XMX value. That is heap size. XMX stands for heap size, right? Try changing. Friend, this is a real case study for a very large insurance company. So let me share their baseline report, how it was looking, right? Let me share their baseline report, how it was looking. And let me also share with you the optimized report. Okay, so and looking at this, look at this, my friends. So this is that insurance companies. Look at the throughput. It was 96%. So it means stopping for 1 hour every single day, every JVM. Look at this. This is for a 10-day window. You see how ugly, how intense it is. You can see the GCs is keep on running. So you see this very intense activity here. So it was timing on a lot of customer transactions are timing out. What they did, look at this, their heap size was, look at the young generation size was 2 GB and old generation size was 6 GB. Together it was 8 GB. Now, based on the tuning, what they did, they increased it. Look, they changed the young generation to 3.5 and 8. So basically from 8 GB, they went to total 8 GB, they went to 11.5 GB. When they did it, look at the throughput. It became 99%. Phenomenal increase. Look what has happened to that thing. So even now, the GCs are running during the daytime. This is a 10-day window, right? It's running. But look at the intensity has dropped. Look earlier, look how intensely it was running. Kept on running all through the day. So intense. Whereas now, it is running very infrequently during daytime. You can see, right? Phenomenal gain. So changing the heap size can give you a very big upliftment. And then the fourth one, what you want to do is try looking at resizing your generation. See, the JVM has generations, young generation, old generation, metaspace. Right? Resizing that can also give you the improvement. See, friends, so this is the very first report that we were looking. Yeah. So this is the cloud provider, right, which had that 96% pause time. You see, you recall, this is what we are looking at the very first of this thing. It had like this 14 seconds pause times, right? See, based on the GC causes, Look, their young generation and the old generation size was kept at 14 GB, 14 GB. That's what they kept, 50 percentage. And the throughput was like a 96 percentage. And look at the average pause time was 12 seconds. Now, what they did, they reduced their young generation size. They made their young generation very small, 1 GB. Reminder, 28 GB was made as old generation. They just made the young generation smaller. When they did, look what has happened. The throughput became like a 99 percentage. Wonderful improvement. And the pause time became like 138 milliseconds, right? Where was 12 seconds and where is 138 milliseconds? Phenomenal drop just by changing the generation size, a single parameter change. Okay. So now let me move on to the next one. Friends, the choice of the garbage collection algorithm also plays a very influential role in your GC performance. See, I told there are 7 GC algorithms, right? In that, which GC algorithm you want to choose, because that will make an impact your application. Friends, in this 7, you can eliminate 1, 3, and 7, serial, CMS, and epsilon, because serial was there since Java 1, which was there when it's a single-threaded GC algorithm, which is not recommended, which was there for initial reasons, which is no longer needed. You can eliminate it. CMS, concurrent mark and sweep algorithm. This algorithm has got deprecated in Java 9 and removed in Java 14. So even though if you're going to be running on any versions before 14, you don't want to be using this one because it has been removed or terminated. You don't want to use an unsupported algorithm, right? And the epsilon is basically a no-op GC algorithm. That means no GC runs. So you're left only with these 4 GC algorithms to choose. Out of these 4, which one to choose? Here is I've given a flowchart based on what is your heap size, what is your GC tuning goal. You can end up with either one of them, right? You can choose one of them. So this flowchart, based on this, you can look at it. So we are going to be sharing this deck, so you can look into that and then you can see how to do it. Okay. Okay, friends. Here is a real-world case study of an robotics application in European Union, right? It was in European Union, a robotic application. Let me show you that baseline report, how it was looking like. When they switched the GC algorithm, what happened to them? Let me show that. Okay. So friends, look at this. They were running. So this is a robotics application which was used in warehouses. So this application gives instruction to robots. So robots, based on the instruction, it does the shipping and the packaging, right? Look at this one GC event. Look, it stopped for 329 milliseconds. What is it? It means 5 minutes and 29 seconds it was stopping. So what? 5 minutes, 5.5 minutes, it was stopping, not giving any instruction to robots. So robots was going chaotic. There were a lot of operational inefficiencies. It was never allowed, right? So after seeing this, what they did, they switched from CMS algorithm to G1 GC algorithm. When they switched, they had still some issues, but that max pause time, what was that max pause time? Look at that. It became like enough 2 seconds. There's no more that 5+ minutes are there. It's gone. So switching this GC algorithms can give you elevate the GC pressures what you have. The 7th one is, okay, now we have chosen what type of GC algorithm we have. The 7th tip what I want to share is, okay, there are 600 plus GC arguments, but what we have done is we have curated and given you a handful of GC arguments for you to tweak and play with it. Say if you're going to be using ZGC, in this GC, we are just saying, just focus on these algorithms, these properties, whatever is here. This is all you need. You don't want to be focusing on all those. You just curated and giving you like a 5 or 6 arguments for each algorithm. That's all you need to be focusing on. So play with this and see whether you're going to see an improvement or not. Okay. So then, my friends, the next tip, right? There are some patterns which will start to occur in your GC log, right? When those patterns occur, it indicates that a kernel or the machine which you're running does not have sufficient resources. It could be lack of CPU or lack of IO. Then the GC behavior will be distorted. When that happens, we report it. In that circumstance, you want to allocate more resources, more system capacity, okay, to handle it. Or you want to increase your garbage collection threads, GC threads you want to increase, right? And the friends, the 9th tip what I want to share, which is the most effective, but very difficult. to implement, which is this high object creation rate. Friends, modern developers, we as a whole, no one cares about writing memory efficient code, right? We don't even think memory is a command. We think it is there, it's cheap, right? We don't care about it. Due to which we are wasting a lot of memory because of poor programming practices, right? So, friends, here there is Paul Allen. He is no more, very unfortunate. He is a Microsoft co-founder. So this idea man is his autobiography. If you get a chance, please read it. It is a very, very fascinating book. How he and Bill Gates started the Microsoft, what happened between them, and how he left Microsoft, and all is very fascinating. But this book, very interestingly, it talks about how modern day developers were wasting memory because of inefficient programming practices. When he and Bill Gates wrote the very first basic compiler, they were able to write it within 2 kilobytes. In 2 kilobytes, we cannot do anything today, right? We cannot do anything. But he talked was very fascinating. So it's just basic discipline, right? Say, for example, here is one example I just want to show. We as a developer, we are writing, whenever we write a code, we are going to create a new array list. This is what we do. We say new array list, and then we say add a user. That's what we do. But what happens underlyingly is when you declare an array list, JVM reserves a space for 10 elements in the memory. And when you say add user, I'm only adding a user for one element. I mean, the remaining 9 elements goes wasted. So like this, we waste memory in 9 different ways. So you can do heap dump analysis through your ePro tool that will tell where all you're wasting the memory. You can optimize it. But when you optimize it, then you're going to create less objects. If you're going to create less objects, that means less time for garbage, right? So doing that, but it involves a code change, which is not an easy thing for us to do because we're all busy with so many things. But it's a very effective practice. That is refactoring and optimizing a code to write a memory efficient code. Okay. So friends, here are some more case studies I want to share. Here are links given. If Uber is saving, automobile, what they did, Jenkins, Oracle, right? What are the approaches, how they did, how they went about optimizing it. They are very interesting to read. If time permits, take a look at it. Okay, friends. So now I come to the end of my talk. I told you I'll answer what is garbage, right? So friends, look at this. See, here I have a water bottle, right? Once I drink this water, and after some time, this is going to become garbage, right? This water bottle will become garbage. And let's say I have my cell phone here, right? This cell phone, say after a few years, once I'm done using it, it becomes very unresponsive. This will become garbage. So if you see, pretty much all the objects, all the materials we use are garbage, right? It's just a time span. In fact, the speaker, that is me, Ram Lakshman, once I die, I'll become a garbage. Right? Isn't it? Yeah. When I say this in some conferences, the audience at me, they laugh at me. Then I say, people who are laughing at me, you are also going to become garbage. Right? So if you see, pretty much everything is a garbage. It's just the time. That's all it matters. So in this time that is allotted to us, let's all work and let's try to see whether we can make any positive impact, at least in a small way, right? Okay, friends. With this, I'm coming to end of my this month webinar. We will see you in a next month webinar. Thank you, everyone.